Good morning or good evening. I'm glad to see you again, Last.fs users, administrators, and developers. Customers are used to ask me how to deal with aged file systems. They see some performance drop, then their targets became quite filled. They see that E2FS procs utilities works slow. They see that some OSs are faster than others. So this presentation is going to give some advices how to deal with these systems. It is mostly about LDiskFS based file systems. First general problem is fragmentation. So then partition became fragmented. We see some strange effects. So then a partition is empty. Block allocator try to allocate as much free blocks as possible. It starts from some allocation window. Then if allocation finished successfully, it increases window, and step by step it sets very large allocation window. But in the situation then partition is quite fragmented, allocator cannot find enough large range of free blocks, and it spent a lot of time processing whole partition from start to end, not one time, but in some cases even 4 times. Fortunately, there are some solutions. First is based on MB group output. This file shows how much free block ranges exist in each group of partition. This data can be used to build new prealloc table. Prealloc table is used to set new allocation window. So the larger numbers are in this prealloc table, the larger prealloc window is. So try to prevent from growing preallocation window by reducing prealloc table. In real cluster systems, we use special script that process MB groups and exclude numbers that are too large. So prealloc table has only numbers that correspond to this real partition. This works well as practice shows. Another approach is based on Last.fs patch that adds 3 thresholds. Each of them sets the value that can be used to decide whether we need to skip MB allocator optimization loop or not. So default values are shown in this picture. Then partition become filled to these values. If this optimization is enabled, optimization loops started to be passed. This allows to use quite filled and fragmented file system without any performance drop. So all these problems are possible because of allocator behavior. So allocator need to iterate other wall partition to find appropriate group to allocate data. If we have some information about group that can be accessed quickly, then we shouldn't spend a lot of time to find appropriate group. There is a solution that already landed to the kernel ext4 and now is being leading to last.fs in the issue that shown in this picture. This approach adds two kinds of data structures. First is linked list that used in CR1 loop to quickly catch large enough range of free blocks. There are lists for each free range size. So then allocator needs such a large range in CR1. It just get the first range from this list. On the CR2 loop, red-black tree is used. Such a tree has all three block ranges in entire partition, so block allocator can find appropriate one quickly, following from a root of a tree until the requested range. I have mentioned that edged file system sometimes became slower. Also, customers see that OSTs sometimes unbalanced, and partitions that have MB last group near start of partition are faster than ones that have MB last group near the end of the disk. This is because spinning hard drive is faster at the start and slower at the end. So customers even see 1/3 performance drop for ISTs with high MB last group. What solution is in this situation? The simplest one is just set 0 to this value. So pointer now sets to the start of the disk. There data can be read and written faster. But this approach has its disadvantages. Because in some situation there are no free blocks at the start of the partition, and allocator need to skip filled groups before it can find a group with appropriate range of free blocks. So we could use something more difficult here. We can use MB groups information again. As I mentioned, this output has information about each group and which ranges of free blocks there. So this output can be processed by script, so we can find first group from start of partition which have enough large range of free blocks. Or, as I mentioned before, currently local allocator is being rewritten completely, and after a new allocator will be integrated, I believe this problem is not possible, because allocator gives free blocks range not dependent with current position, but just the first one from linked list or red black tree. The next problem is connected with directories. As you know, we have large directory option now that allows users to create as much files as they want. But as practice shows, the bigger directory is, the slower it acts, unfortunately. The problem is because the more files you write to the directory, the more levels of tree are used. So before 100,000 files in the one directory, we have only one level tree, and it's quite fast. So after 10 millions for directory with average names, performance drop become quite valuable. So this is the reason why we should avoid of using too large directories as much as possible. For example, on ASTs, quite large directories can be created currently because sequence is adjusted to have a lot of entries. But currently this number is reduced, so we should not have a lot of names in the same directory, and this avoids us from performance drop. But as I said, if we need to store a lot of names in the same directory, for example, then we have only one MDT and need to start some kind of acceptance tests, we always can enable large dir and create as much names as we want. Another issue connected with directories is the fact that a directory can only grow. So then somebody adds a lot of names in the same directory and then delete them. Directory size stay the same, and currently there is only one way to make it smaller, is to rebuild such a directory using E2FSCK with FD options. But some attempts to solve this problem are currently exist. There is ext4 patch that forced to clean last block of directory if it became empty. So metadata can become fragmented not only because of lifetime of file system. Some metadata is fragmented from the moment the file system is created or formatted. So after partition became larger than 2056 terabytes, we cannot format them without big alloc or MetaBG options. And unfortunately, MetaBG has its disadvantages. This picture shows that if we do not use MetaBG option, all block groups metadata is stored at the start of disk, and it is continuous. So we can use some preload optimization, and file system is mounted quite fast. But if we use MetaBG, the same information is split across the entire partition. So during file system mount, this data is being read by 4 kilobytes chunks. So preload optimization doesn't work in this situation, and even rate optimization doesn't work because of the same offset this chunk has. All of these chunks are placed to the same disk of rate massive, and rate optimization doesn't work. So what should we do in this situation? First of all, we do not use MetaBG and use big alloc, but big alloc has its own disadvantages. If we want to use MetaBG, we could make these steps. That is a nice workaround. We can format first part of partition under 2056 terabyte without MetaBG option, and then resize it to the whole partition. So metadata for first part of partition is stored continuously, and only part that exceeds this number is formatted with MetaBG and fragmented. These tests can be done manually in scripts, or we could improve MakeFS utility for such behavior. To fix this problem in ext4, ext4 format should be rewritten completely. Then something bad happens. We need to use ITFS prox utilities. That works quite slow for really large partitions. Customers came and reported that ITFSK spent 8 hours, even 36 hours to process a partition. That's why ITFSK has been parallelized. So it is use multi-thread behavior now. So it was noticed that 80% of ITFSK time is being spent in pass 1. So this pass has been optimized in LU 8465. So only inode reading is parallelized, and if some issues should be fixed, they are fixed, still serialized. So it's useful sometimes to get a partition image because maintenance window is about to be closed and we need to investigate some issue. E2 image, quite useful approach. We can store image in qcal2 format and convert it to raw after, or even mount using QEMU functionality and execute E2CK on new device. Or we can save this data directly in RAW and make archive from it. There is some fixes that required for really large partitions. So we need to fix QEMU to open really large partition, and E2 image should be fixed to have a possibility to convert partition. Managed file system has really large configuration files. What should we do then? We need to change some configuration. For example, some address of node. So the old approach requires from us to start a write conf and reconnect every target to the MGS. So configuration should be rebuilt. It's quite a dangerous operation and quite long. Some issues are possible. Fortunately, there is another option. There is replace need command that change need in place. Here is an example of how to nodes addresses can be changed in place. Also, these nodes are in failover to each other. Also, no local logs should be placed to the by tunefs. So during mount, new configurations logs being captured from MGS and no local logs are used. A way to clean up configuration file by excluding records that are marked as skip. It's quite safe operation, executed on MGS while all other targets are disconnected. It's called lktl clerk conf. It can clean exact target configuration files or configuration files of entire file system. This is all issues I want to introduce in my presentation. Of course, this is not all possible ones, but this is that we face it with and have appropriate solutions. So thank you very much for your attention. Any questions, please?